I'm really excited about this episode of Dissecting DevOps because not only are we talking about a really compelling and somewhat new topic matter, but we're also changing up the format. It's going to be more conversational, and we have an expert from the security side of the house at Splunk joining us to cover the conversation. What are we talking about today? Well, it's DevSecOps. Yes, another term that we just kind of throw around in this industry and expect everybody to understand what it means. And there's two key things I want you to leave today understanding. First is that DevSecOps is a practice. So what does that mean? It's not a product. It's not a product you buy and use and now you're doing it. It's not an end. You're never done. It's a journey. It's a practice that you build, and it crosses multiple teams. And it's really important to have this mindset because without this mindset, you may frame your implementation of DevSecOps as a tooling exercise, and it simply is not. The next thing that I really encourage you to leave, or you must, I should say, it's not even a choice. That practice has to be visible. So just like DevOps, a big component of DevSecOps is to facilitate velocity, go fast. However, velocity is meaningless unless it has the guardrails and the road paved for it to make sure that you can continue to go fast over time. And the only way to do that is to make it visible. Now, what does visible mean? Visible is not just the data. As a matter of fact, yes, you have to have the data. That is the core element of it. Without the data, you can't visualize it and you can't use it in analysis and incidents, etc. But you need to have a thread that goes all the way from the activity in your software delivery chain through your tech stack, which includes your infrastructure, your application, and the front end of your application, through to the security tooling you use to make sure that your environments are secure and you are able to respond to vulnerabilities. Now, this is really what I call the code to cloud journey, making sure that what happens from the point that a feature is defined in your ticketing system, your backlog, to what happens to that feature when it's running in production, and what happens when there is an incident. And so you can't just create siloed visibility at each of these layers. You have to make sure that that context is tied together, that is understood across all of your engineering teams, and that everybody is speaking the same language. And at Splunk, we use a term called the common information model. That is kind of the technical implementation of that speaking the same language. And so DevSecOps encompasses all of this because without this visibility, it's very hard to manage and maintain a DevSecOps practice. Now, what are the key characteristics of DevSecOps? Well, first, there is an implication around automation. We do need to try to make sure that our software delivery chain and what happens in production is tied together via automation. You may have heard this term, infrastructure as code, everything is code. Literally, your delivery chain is the application of applications. It is a software service that you deliver to your engineering team to make sure that applications are flowing smoothly all the way into production. And then we have the automation in production to make sure that what we do to make sure that application is up and running is effective and efficient. So automation is a key component of this. The other characteristic is what we're trying to do is take security considerations we usually only had once applications were deployed and taking those considerations and shifting them left. Shift left is another really popular term, but the meat of this is the fact that you want to address stuff early on before it's a problem because one, you want to avoid it, and two, it's a lot more expensive when it happens in production, a lot more expensive. But also there's context, there's data that happens in the software delivery chain that makes security response and the security team's lives better. And then finally, the velocity thing. And I shouldn't say finally, but I beat up on this idea of velocity that yes, we want to go fast, but we want to maintain the integrity of our environment while we go fast. And the DevSecOps practice is all about that. So the other thing, knowing that it's a practice, is that there's several use cases. There's not just one use case. And really, we like to talk about three. The first one is build more secure applications. Embed a security mindset during the actual coding stage of the application development, such that you have better testing and better understanding of code quality, vulnerabilities, etc. So you know you're shipping more secure code. Second is securing the software factory. This is your software delivery chain, making sure that bad actors don't get access to your tool chain in order to exploit the software being built by it. And then finally, the area that we're all very familiar with, I think, and what we tend to talk the most about, although securing the application factory is a huge topic right now, is securing those applications in production and doing a better at responding to incidents when they happen, not if, when. So, because it is a practice, we have three use cases. Those use cases align to practitioners in different ways. It is different for each use case. Building more secure applications ties to the developers, quality engineering, and DevOps engineers as the key personas who are involved in creating it and consuming the data. Secure the application factory usually relates to DevOps engineers, sometimes site reliability engineers, and almost always security professionals. And then securing applications in production are site reliability engineers and security professionals. Now, one thing that this graphic doesn't do a great job of indicating is that site reliability engineers and security professionals are the consumers of the data that the developers and the quality engineers are producing to make this visible. What they need to know is that the practices of vulnerability scanning, code quality are happening. They don't need to be involved in them. They need to know that they're happening. And they need to have an understanding of that without going down the hall and talking to the developers directly. Now, how do these use cases align to the characteristics of the technology you use to build your DevSecOps practice? So the overall visibility is usually driven by technology or capabilities around pipeline analytics, collecting telemetry from your tool chain and visualizing them. Building more secure applications is also pipeline analytics, collecting data from your testing processes and visualizing them. Securing the application factory is a combination of your traditional SIM tools and pipeline analytics. Pipeline analytics for the purpose of visualizing the behavior and the usage of your tools, like secrets management, policies being used, etc. And then the SIM to actually secure those applications from bad actors coming from the web and getting access to your repos, etc. And then finally, securing applications in production. This is something that we all are used to talking about today. So your SIM for securing your production applications, observability for making sure that you have the depth of understanding in the application so that you can better work with the security team and have deeper understanding of what's going on in your application, and incident response or automated remediation to actually address incidents as they occur. So, like I said, the format of this one is a little bit different. The rest of it is just going to be a conversation. And we're going to start with Dave McAllister, who, Dave, can you tell us from the developer's perspective, what do they care about, don't care about? How do they think about application security?
As a developer myself and having worked with developers for a long period of time, application developers, it's a distant secondary thought. It's not usually something that's called out as a top tier priority item. If it's always there, I will admit it's always there. Security is always there. But I'm going to flash back to a company in 2014, 2013, 2011. I've forgotten exactly when it was, when there was a huge breach of user data with Adobe systems. I worked at Adobe at that point in time. I was actually inside the security organization. And prior to that, developers gave us pretty decent lip service. And when we did analysis, they'd go back and fix things. But it wasn't ever part of their upfront discussions for that. 143 million breached records later, all one single breach, by the way, security suddenly became a top of line item for everyone. We did classes, we taught developers, we constantly were being asked about new approaches to doing those things. It suddenly became a very much top of the line item. In fact, I'm going to expand this a little bit. I'm going to point out that I'm willing to bet that none of y'all think about your password environments until you get the notice that says your record's been breached and that you need to change your password. And in my case, literally, I've had a couple of those come in the last week. Thank you, major airline clubs. And the process of doing so is something I didn't think about. I change my password here regularly, but it's not something that's top of mind until it happens to you. So developers really don't think about it. Again, I listen through discussions with developers, and if you ask about security, every single one of them will tell you, yes, it's top of mind. But without the things that are moving to the DevSecOps, without the shift left of security, it's never going to be part of that development process the same way it is as a response process.
Thanks, Dave. Yeah, I know developers like to go and code in cafes and not join a VPN when they do it. So it's quite a challenge. So let's talk about the other side of the house. This is really important to understand that, again, it's a practice. So it involves all of these engineering teams. It involves developers, it involves DevOps engineers, and it involves the security team. You can't neglect those personas. But Mr. Dave Harold, why don't you explain to me from the security side of it, what is the security team thinking now about the software delivery process?
Yeah, well, I like the story that Dave McAllister told about Adobe. It reminds me of kind of the Microsoft story, literally going back almost a generation at this point of, where they were literally kind of a laughing stock in the industry from a security perspective. It was, Microsoft operating systems in particular were so insecure and just the source of so much pain for so many companies. And then, the famous memo from Bill Gates, right? The trusted computing memo. This is around Windows XP SP2 time frame, right? When he came out and basically said, I'm Bill Gates, this is Microsoft. And, if you have a choice between anything else in security, you have to choose security, and essentially change the culture by doing that. And now you look at it like I said, a generation later, and Microsoft is basically arguably the most influential positive force in security, like in computing, right? And that's a cool story about how that can change from the top. How do you start to secure this new sort of surface area from a security perspective? Like, how do you secure applications without that, right? So I think what you see instead, to get to your question, Chris, is you see, okay, we have a CISO, right, in our organization, or a director of security. It's pretty natural to push the responsibility for security to that persona. And then you also have this trend of everything is becoming an app, right? Software is eating the world, or has eaten it. And really we still have Exchange servers sitting out there, and we have endpoint computers, and we have networks to monitor all the old stuff that we worried about from security. But we have this very growing set of assets in our customer organizations that are apps, and that are maybe products, right? Apps that are internally used, or apps that are products. So we're not only increasing the surface area of things that can be attacked in our organization, but are maybe I'm creating something that's increasing that surface area for my customers, because they're going to run my software in their environment. So if you put yourself in the CISO's shoes, how do they do what they were hired to do, right? Which is reduce risk in the organization, yet allow the organization to thrive and take advantage of their market opportunity. How do you do that when you're typically not in charge of sort of you're not in charge of delivering that app, but you're in charge of securing it. And the way I look at that is you mentioned that concept earlier, Chris, of paved roads, right? And I think that to have a chance at succeeding from a security perspective, number one, you do have to have that visibility. Handoffs kill, right? Anytime you have to do a handoff or anytime you have to do a relaying of information between humans, you've pretty much just destroyed your time to respond, right? So having that ability for everybody to be on the same page and see the same information, whether you're a developer or whether you're a DevOps engineer, SRE, or whether you're a security person, everybody has a common source of truth. I think that's a huge thing. And then secondly, as a CISO, like I can't, I'm not in charge of creating those apps, but what I can do is pave some roads that lead to good outcomes, right? So what I can say is, hey, here's a way to log from an application, right? Like here's a standard way, here's maybe the standard things that you would put in a log message. It's the standard way that you would transmit that log message to something like Splunk, leads to that common visibility. Or maybe you say things like, hey, here's the secrets management tool that we're going to use, and make it very easy, pave that road, right? Make it very easy for developers to do those things. What the developers want to hear is don't slow me down, right? And so the message to them is, hey, if you stay on the paved roads that lead to these good outcomes, I'm not going to slow you down. I'm not going to add another audit step. I'm not going to, stop this automated train that you have to go manually approve something. I'm only going to do that stuff which you don't like if you take the side road, right? And I think that generally is a recipe for success. And so that CISO can provide these sort of can provide these roadmaps for developers. And I think, as I think about this a lot, and I think that metaphor is probably the one that's most useful to think about.
Yep. Can I share a slide real quick? This is something, and you really hit me on 2 points here, and I'm gonna ask a question. But this came out of Eurocontrol, and I forgot how long ago this white paper is, but it talks about safety. And in some ways we are talking security versus safety. And we have 2 activities that focus on this. Right now, I feel like a lot of our security focus is on this what's called safety 1. What has happened with the accident? What's happened with the incident inside of here? And as you can see, it's actually a really small portion of the activity that goes on a daily basis here around this. And what I think we're trying to do with this DevSecOps discussion is move to this safety 2. How does this impact us every single day? Spend a lot of time talking about this concept of observability or practical monitoring and things like this. Sometimes I don't want to know just what went wrong. I want to know what's going right as well. And I think this is something that security hasn't spent a lot of time looking at. And the reason I'm doing this is back to that paved road model here. What is the right paved road, not just what is a paved road inside of here? The question I want to throw your way, Dave, we talk about things like error budgets, where you take the number 100%, you pick your SLA, you subtract the SLA from 100%, and that's how many errors you're allowed to have. And does something like that also make sense for us to throw at a developer community where we now have a breach budget of some sort? Now, it's not going to be 1%. I want it to be as close to 0 as possible, but it gives me a measurable aspect. As a numbers guy, I like to measure things a little bit.
Yeah.
So throw that your way.
Sure. Well, I mean, I love that concept of, certainly, there's never any such thing as 100% secure or 100% reliable, and in other endeavors, from a software engineering perspective. And I think for CISO and for security in general, right, I think that, one thing that's generally true is that usually the organization is in the business of getting more software out faster, that does more things, that helps their customer more. Like that is the business. Having sort of a binary view on things from a security perspective is usually a recipe for disaster, right? And so if you start setting a precedent as a security team of stopping deployments stopping release
Yeah.
of new software, new features, you're going to be gone, right?
That's called redefining the test. That
Yeah,
literally the past. Yeah, if you block me every single time, I'll redefine the test so I can pass it.
that actually absolutely happens, and I do the same thing. Like, I spend a lot of time writing software as well. Here at Splunk, I write software for things, and it's just really weird how even I recognize in my own self a Jekyll and Hyde mentality of like, hey, if I had my security hat on right now, I would be mad at me with my developer hat on. What we're starting to see, like on the security side at Splunk, is like a concept of our risk-based alerting, which is it's a technique for taking a bunch of indicators. So, hey, here's a thing that maybe is bad that happened over here. Here's something also that is some degree of bad, right? What RBA does is allow us to take a whole bunch of those little indicators and pull them together, and then sort of aggregate them and say, hey, does this rise to the level of me, wanting to use my very scarce resource of like stopping this product from being deployed, right? And I think that those are the kinds of things that we need to arm security with, so that they can have a more nuanced view of how they impact these things, right? Because if you just come in, I mean, I remember back in the days when I used to, it was like caveman security, right? Like, I worked at a payments software company, and we had these really complex systems that did credit card payments and other types of bank transfers and things like that. And I was in charge of security, right? And I would run my security tools against the software, and it would literally generate 100 pages. I mean, if you were lucky, it was only 100 pages of output, right? And it only takes one time to take that report and like set it on the developer's desk before you realize, like, okay, this is not going to work, right? There's no hope of them fixing it, nor should they, right? So it's a matter of, like, in my opinion, like figuring out how we aggregate those things up and allow us to make some sort of a nuanced decision of whether the amount of risk represented there is something that we want to step in and say, no, we got to stop. Fitting that sort of line of reasoning to DevSecOps, I think, has a lot of promise.
Well, thank you, both of you. And I'm going to just wrap up with that comment about the nuance. It is nuanced. And that's the reason why we say DevSecOps is a practice. And for that practice to be successful, you have to have visibility. Visibility is the paved road. And you need visibility for all three use cases: building more secure applications, securing the software factory, and securing and responding to incidents inside of production.